अस्सलाम वालेकुम। क्या हाल है आप लोगों के? Ceasefire, yeah, I just read. Is it confirmed? Sir, I couldn't do your playlist because of last night. What do you mean? Not sure I understand. Acha, for some reason, internet is not 100%. So if you get disconnected or something, I'm really sorry about that. So please put PDF link in description. Yeah, you will find it. You will find it. I just uploaded it. Please check. You will find a link in the description. अब बॉस ने बोल दिया सीज फायर तो फिर तो करना ही पड़ेगा. अच्छा, stream is lagging. Just a minute. Let me switch internet connections. बेटा discrete. ओके, अब सही है. Sir, switching internet, yeah. Sir, India ने PD से. Don't forget to do revision for S2. But I don't teach S2. I don't teach S2. So there is a playlist by Sir Ahmed Saya where he's completed all of S2. So I will recommend that to you. But I don't teach S2. I don't teach S2. I don't teach further math. Anyway, so start करें. Let's start. So we're going to solve inshallah lots and lots of. नहीं बेटा, अच्छा देखो. Concepts मैं नहीं कराऊंगा because I've made a very detailed playlist on permutations, combinations already. So I told you guys yesterday when I was doing normal distribution that you should watch the concepts because we can only do one thing at a time. If I do concepts, then we will only be able to do concepts. Okay, we won't be able to do any past paper questions. I've already covered all the concepts in a lot of detail. I will encourage you guys to watch that stream. It's not a stream actually, it's a playlist where you can literally cover it from scratch, and then you can watch this stream later where we'll be doing past paper questions. Okay, so let's start. Now, let's start with some relatively simpler questions, and then we'll gradually increase the difficulty level of the questions. Now, my aim is to solve at least 20-25 questions. Okay. Now, Richard has 3 blue candles, 2 red candles. This is a question from February-March 2020, paper 5, variant 2. Okay. Richard has 3 blue candles, 2 red candles, and 6 green candles. The candles are identical apart from their color. So that means if all there are blue, so all the blue are identical, all the red are identical, and all the green are identical. Is showing add maths? Oh, sorry, मैं change करना भूल गया. कहीं add maths वाले परेशान ना हो जाएं कि मैं क्या पढ़ा रहा हूँ. Tero, thank you for pointing that out. I'll just quickly change that. There you go. Okay, now find the number of different arrangements of the 11 candles if there is a red candle at each end. Now, because the 2 red candles are identical, so first of all, start by making 11 blanks. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, if you want a red candle here and if you want a red candle here, because they're both identical, so we can't do this. For example, we can't do this. We can't say that we have 2 options here and we have 1 option here. Considering that I want a red candle on each end, I can't say that I have 2 options here and I have 1 option here. Why? Because all the red candles are identical, all the green candles are identical, all the blue candles are identical. Even if you do this, you will ultimately have to divide it by 2 factorial anyway. Okay, even if you do this, you will ultimately have to divide it by 2 factorial anyway. So instead of that, we're just going to say that we have a red candle here and we have a red candle over here. Okay. Now, what about in between? Now, remember, these are 11 candles. Okay, so that means we have 11 spaces. So in between, since there are 9 candles, we can do 9 factorial. But that's the thing. We can't just leave it at 9 factorial because inside there are 3 blue candles. So we have to divide by 3 factorial. And inside this box, okay, in the remaining, in this space where we have 9 candles, there are also 6 green candles. So we have to divide by 6 factorial as well. Okay. So what does that mean? That means 9 factorial divided by 3 factorial into 6 factorial. Okay, it's February, March 2020. There's only one variant for February, March 2020. So that would be variant 2. Okay, so work this out and that's it. This will give you a final answer. Okay, let's see what we get. So we get 9 factorial divided by 3 factorial into 6 factorial. That's equal to 84. Okay, now find the number of different arrangements of the 11 candles if all the blue candles are together and the red candles are not together. Okay, blue candles are together and the red candles are not together. So let's do one thing. Let's first find out the number of ways that we can keep only the blue candles together. Okay, let's find out the number of ways that we can keep only the blue candles together. Now, we don't need to think about switching red candles places. Reason why we don't need to think about that is because they're identical. Even if you do that, okay, even if you multiply it by 2, you will have to divide by 2 factorial because they're identical. Okay, if let's say they were not identical, if let's say this was people, okay, let's say A stands at one end and B stands at the other, then you would have to think about switching. But these candles are identical, that's why we don't have to think about switching. Okay, so I'll mention that over here, that the reason why we don't do 2 factorial, okay, reason why we don't do 2 factorial is because the red candles are identical. The red candles are identical. Why divide by 3 factorial, not 2 factorial? Because inside here we have 3 blue and we have 6 green. Okay, so what's this 3 for? This is for blue. Okay, and what's this for? This is for green. Okay, now, so let's keep the blue candles together. So start by making 11 blanks. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, now, if I want to keep blue together, we're going to put them inside a box. Okay, we're going to treat them as one unit. Now, inside the box, normally we do 3 factorial. Now, here also, if you do end up doing 3 factorial, just remember that the blue are identical, so you might as well divide by 3 factorial. Okay, so what's this 3 factorial divided by 3 factorial for? That's to consider how the number of blue candles inside can shuffle. 3 factorial because there are 3 of them, and divide by 3 factorial because they're all identical. Okay, now what about the rest? How many units do you have now in total? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, don't rush into it. I would suggest, if you guys want to solve this yourself, then might as well just download the PDF and start solving on your own. But my suggestion to you would be that if you want to make the most of this stream, just watch me solve them. I'll give you guys questions to solve in between. Okay, this is going to be a very long stream, so don't worry about it. All right, so except for the blue candles, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So if I ignore the blue candles, there are 2 red candles and there are 6 green candles, and they are identical. So that means we will divide 9 factorial by 2 factorial and 6 factorial. Okay, let's see what this turns out to be. So this turns out to be 9 factorial divided by 2 factorial into 6 factorial. So this is equal to 252. So this is basically the number of ways that the blue candles are together. Now let's find out the number of ways that blue are together and red are also together. Let's find out the number of ways that blue and red both are together. Okay, so once again, we start by making 11 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. आवाज कम आ रही है? I don't think that's an issue. But अगर कम आ रही है तो मुझे ज़रा बता दे कोई. So let's put the blue candles in a box. Okay. And let's put the red candles in a box also. Okay, so for the blue candles, that's going to be 3 factorial divided by 3 factorial for the red candles. Okay, so this is for blue, this is for red. For the red candles, it's going to be 2 factorial divided by 2 factorial. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Now 3 factorial divided by 3 factorial. Achha, you might as well not do this at all. ये मैं इसलिए कर रहा हूँ दिखाने के लिए कि because this is the standard. Okay, reason why we don't have to do it over here is because they're all identical. Into 8 factorial. Okay, and don't forget that in the remaining candles, there are basically 6 green identical candles, so that would be divided by 6 factorial. So let's work this out. 8 factorial divided by 6 factorial. What's that equal to? That's equal to 56. Now what do we do with this? What do I do with this? What do I do with these candles? I mean, all this working that I've done, what do you suggest I do with it? Basically, what have we done? We have found out the number of ways that we can keep. We found out the number of ways that blue are together. Okay. And we found out the number of ways that blue and red are together. So if I subtract them, I will get what? I will get the number of ways that blue are together and red are not together. Okay, so if I subtract the two, I will get the number of ways that blue are together and the red are not together. So 256 minus 56. Oh, sorry, 252 minus 56. 252 minus 56, what's that equal to? That's equal to 196. Why did I divide by 6 factorial? Because there are 6 green identical candles. See, if you lose, if for a second you lose your focus, you will be completely blank as to what's going on. Okay? If for a second you lose your focus, you'll have no idea what's going on. Acha, in case there are any AdMath students watching this, please don't. Okay? Please, AdMath students, I don't recommend that you guys watch this. Okay? It's not necessary for you guys to watch this. It's very difficult compared to AdMaths. Okay, I'll explain this again. Notice the question says that find out the number of ways that blue candles are together and the red candles are not together. Okay, so there are 2 conditions. Blue is together and the red is not together. Okay, this worksheet is available in the link in description. Link मैंने डाला हुआ है ना, कोई ज़रा confirm करके बता दे please. So let's find out the number of ways that we can have the blue candles together. Okay, so that becomes our total. Okay, the total number of ways in which we can have blue candles together. And let's also find out the number of ways that blue and red are together. Okay, so blue and red candles are together. That is basically equal to 56. And earlier we found the number of ways that blue candles are together. That's 252. अगर मैं दोनों को subtract कर लूँगा, तो मेरे पास क्या आ जाएगा? मेरे पास आ जाएगा the total number of ways that blue is together and red is not together. Okay, because if I subtract from blue together the number of ways blue and red are also together, I will have the number of ways in which blue are together but red is not together. Okay, so I've done the opposite. What would be the opposite of blue candles are together and the red candles are not together? Just focus on this part. Okay, let's keep this constant. Focus on this part. What would be the opposite of this? The opposite of this would be that red candles are together. Okay, so we subtract that and we get the number of ways that the red candles are not together. Okay? All right. Now, next question. Find the number of different possible arrangements of the 9 words in the word celestial. So very simple. These are 9 letters, so 9 factorial divided by the repetition. So we have E that occurs twice. Okay. Acha, what's your question? Sir, why did you minus blue and red? But just send your question again. Okay? Instead of saying के answer your question, just send your question again. Okay? वो question ऊपर चला जाता है, फिर मुझे ढूंढना पड़ता है. So 9 factorial divided by 2 factorial into 2 factorial. Let's see what that is. 9 factorial over 2 into 2. That's equal to 90,270. 90,270. Won't we have red together after subtraction? Nope. Since we have subtracted the number of ways that red will be together, we will have the number of ways that red will not be together. Okay, once again, have a look. What have we subtracted? Here's what we have done. We have done blue together. Okay, the total number of ways that blue can be together. Minus blue together and red together. So जब आप ये minus करोगे, what will you have? Okay, so you'll have blue together and red not together. So you can now learn this concept very well because this is something that's tested very, very often. Okay, this is something that's tested very, very often. Why didn't you subtract the total by blue and red? And why did you do the blue and red with red? Okay, because there is one condition. देखो अगर तो ये condition होती है ना that red are not together. Okay, if let's say the condition was that red are not together, then we would have found the total, and from that we would have subtracted the number of ways that red are together. Okay, but because the condition is that blue has to be together and red has to not be together, so we find out the number of ways that blue is together. Okay, now in that you have all the ways that, so basically that's your total now. You find out the number of ways that blue is together, that's your total. From that you subtract the number of ways that blue is together and red is also together. Okay, so if you subtract that, logically socho, blue together minus blue together, red together, what do you get? You get blue together, okay, and you get red not together. Simple as that. ठीक है? Okay, now part B. Find the number of different arrangements. क्योंकि देखो ये हमारी, this is our, so think of it this way. This is our consistent condition. Okay, this is our greater condition. And this is the smaller condition. So first we fix this condition. Okay, then we find out the opposite of this condition while remaining under this condition. Okay, and then we subtract it from the total. Simple. Acha, beta, when we get to that question, okay, I do plan on solving those probability questions, so you'll find out. Okay, so we will be doing those probability questions as well. Not immediately, obviously, we can't dive straight into it. Okay, but when we get to that, you'll find out. All right, ceasefire announced. Chale, alhamdulillah, अच्छी बात है. Now, Sir Zain said when you're solving PNC questions involving probability, we don't regard repetitive cases as separate and take. Okay, beta, I don't know in what context you mean that. Okay, but when we get to probability questions, you'll find out. Okay, Abhi, let's not make things more complicated than they already are. When we get to probability questions, we'll find out. Okay, now part B. Part B says, find the number of different arrangements of the 9 letters in which the first letter is a C, the fifth letter is a T, and the last letter is E. Okay, so please make sure that you guys read the question carefully because majority of the times you guys ask me something that's already written in the question. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so here's the condition. First letter is a C, fifth letter, 1, 2, 3, 4, 5, is T, and the last letter is E. 6, 7, 8, 9. Okay, so that means we can't shuffle these letters. Okay, we can't. Acha, is it 720? Yeah, it's 720, not 270, it's 720. This is May June 2020, paper 5, variant 3. So what are the letters that we can shuffle? We can shuffle 1, 2, 3, 4, 5, 6. So that means there are 6 letters that we can shuffle. Okay, now we have to see that amongst these 6 letters, are there any letters that are being repeated? Let's see. So since we've dealt with C, we're going to cross that out. Since we've dealt with T, we're going to cross that out. Since we've dealt with E, we're going to cross that out. Okay, now the only letters that are repeating are the 2 L's. So that means 6 factorial divided by 2 factorial. That's it. That's all we have to worry about. 6 factorial divided by 2 factorial. What's that equal to? That's equal to 360. Okay, why didn't I do divide by 2 factorial for the 2 E's? Because 1 E is fixed, so now we don't have to worry about the 2 E's coming together. Okay, now part C. Part C says, find the probability that, Beta, मैंने दोबारा पहले भी बोला है कि instead of asking me to answer your question again and again, just resend your question because then I'll have to sit through the chat and find out what your question was. Okay, now find the probability that a randomly chosen arrangement of the 9 letters in the word celestial does not have the 2 E's together. Okay, so first of all, this is probability. Keep that in mind. Okay. Secondly, this is does not have the two E's together. Okay? So how will we work this out? Simple. In order to find out this probability, we will, in the numerator, we will have the number of ways that E's are not together. E's not together divided by the total. Okay, so this is what we have to do. E's not together, divide by the total. Now the question is, how will we find out the number of ways that E's are not together? Here's what we will do. Total minus E's together will give us what? Will give us the number of ways that E's are not together. Okay? So total minus E's together will give us the number of ways E's are not together. So this is May, June 2020, paper 5, variant 3. Okay, now we've already worked out the total. Let's find out the number of ways that E's can be together. Now how many letters are we dealing with? We're dealing with 9 letters. So for E's together, let's do the working over here. E's together. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if you want the E's to be together, put them in a box. Okay, so what's that equal to? That's equal to 2 factorial divided by 2 factorial. Okay, 2 factorial divided by 2 factorial. This is for the 2 E's. Now, how many units do we have? 1, 2, 3, 4, 5, 6, 7, 8. So we'll multiply it by 8 factorial. But don't forget that there are 2 L's. Okay, so we'll have to divide by 2 factorial as well. So that means, in short, we just have to do 8 factorial divided by 2 factorial. What's that equal to? That's equal to 20,160. So we found out the number of ways that E's are together. If I subtract that from the total, which is 90,720, so 90,720 minus 20,160 will give us the number of ways that E's are not together. So 70,560. This is the number of ways that E's are not together. Okay. So 70,560 divided by the total, which is 90,720. Let's work this out. Divide by 90,720. That's equal to 7 upon 9. अच्छा देखो बेटा वो जो repetition की बात आप लोग कर रहे हो ना, we take that in combination. Okay, this is not a combination question, this is an arrangement question. Okay, this is not a combination question, this is an arrangement question. Okay, so what you guys are saying, there's 2C1, 1C1, that is basically when we're doing combination. Okay, we do that when we're using combination. Okay, so there you go. I'll quickly go over this. So if for a minute we forget the fact that this question is a probability question, if let's say the question says that find the number of ways that the E's are not together. So what are we going to do? We're going to do total minus E's together. So total is right here, which is 90,720. From that, we subtract the number of ways that E's are together. Okay, and we get the number of ways that E's are not together. Okay, the repetition part that you guys are constantly talking about, that happens in combination. And yeah, what is the pocket method? I don't know what you're talking about. ठीक है. So ये जो आप लोग repetition की बात कर रहे हैं ना, repetition हम सिर्फ consider करते हैं जब हम probability कर रहे होते हैं, और वो भी combination में. Okay, वो भी combination में. I think what you guys need to do is you guys need to watch the concepts wali playlist. Okay, I will strongly recommend that you guys watch the combination playlist. Why do you divide 2 factorial by 2 factorial? Because there are 2 E's. Okay, so how can you shuffle 2 E's? That's 2 factorial. Divide by 2 factorial because they're identical. You can ignore that. It doesn't make a difference, but it's a good habit to do that. अच्छा बेटा ये इतनी जल्दी क्या है आपको? शेख साहब आपको इतनी जल्दी क्या है? आपका पेपर पहले है क्या? हाँ, आपका पेपर पहले लेना है कैम्ब्रिज वालों ने? नहीं ना? ठीक है, तो ज़रा calm down. When we get to probability, when we get to combination, you'll find out. ठीक है. All right, now part D. Let's see what part D says. So part D says 5 letters are selected at random. from the 9 letters in the word celestial. Find the number of different selections if the 5 letters include at least one D and at least one E and at most one L. Okay, first of all, why are you typing in caps? It seems as if you're shouting. And I've already done geometric distribution. Okay, I've already done geometric distribution. All right, now let's see what this is. So we have to make sure that there is at least one E, okay, and there is at most one L, okay, and there's no probability here. We just have to find out the number of different selections. Okay, we have to find out the number of different selections. So bear that in mind. There's no probability over here. So we're talking about at least one E and at most one L. So let's start with one E, and at most one L means that we can have 0 L, we can have 1 L, not more than that. Okay, so let's keep this fixed for now. Okay, let's keep this at 1 and let's keep this at 0 as 0. So 1 E and 0 L. Okay, so how many letters do we want? We want 5 letters. 1, 2, 3, 4, 5. Okay, and a good idea would be to write the word next to you every single time. ठीक हो गया? Okay, here we go. Now, if there is one E confirmed, and we have to make sure that we don't select any other E, and we have to make sure that we don't select any L, so we cross out the E's, we cross out the L's. Okay, that means now we're down to how many letters? We're down to 1, 2, 3, 4, 5. We're down to 5 letters, and we have to select how many of them? We have to select 4 of them. So that's 5C4. Okay, what's that equal to? Let's work this out. 5C4, that's equal to 5. Okay, now it's possible to have one E and one L. Okay, it's possible to have one E and one L. So 1, 2, 3, 4, 5. Now one E and one L. So once again, we've selected one E. Okay, so we can't have any more E. So we cross that out. We can't have any more L. So once again, we're down to 5 letters, and we have to select how many of them? We have to select 3 of them. So 5C3, what's that equal to? 5C3 is equals to 10. देखो, repetitions सिर्फ और सिर्फ combinations और probability में count होते हैं. Okay? So reason why I didn't do 2C1 over here is because this is not probability. Okay, Abdullah and Sheikh. Reason why I didn't do 2C1 over here, this is not probability. We just have to find out the number of different selections. Okay, so I'll make a note over here. When finding the number of different selections, repetitions are not to be considered. Okay, but when finding probability, you have to consider repetitions. Okay. All right, now it's possible to have 2E and 0L. That's possible because you can have at least one E. That means you can have more than one, but you can have at most one L. So that means it's possible to have 0. Okay, when we get to probability, I'll explain why we do 2C1. Okay, when we get to probability, I'll explain why we do 2C1. Right now, don't worry about it. So E. Now, once again, we're down to 5 letters, and we have to select how many of them? We have to select 3 of them. So 5C3, what's that equal to? That's equal to 10. Achha, any other condition to consider? Yes. 2E and 1L. Yeah, we can consider that. So once again, 1, 2, 3, 4, 5. So 2E and 1L. So here's E, and L. Once again, we're down to 5 letters. We have to select 2 of them. So 5C2, what's that equal to? That's equal to 10. Now, what's the total? The total is equal to 10 plus 10, that's 20. 20 plus 10, that's 30. That's equal to 35. There you go. Okay, so I'll make a note over here once and for all. When finding number of different selections, repetition is not to be considered. Okay, meaning that even if you have 2 E's, we will consider it as 1 only. Okay, All right. So what's the total? The total is 35. All right, let's do some more questions similar to this. Okay, let's do some more questions similar to this. Let's do the next question. Question number 4. So question 4 says, agar ceasefire ho gayi, so that means papers will be as per schedule. Everything will go, inshallah, go back to normal. So all the more reason for you guys to study. Okay? Now, let's see what this says. Find the number of different arrangements that can be made from the 9 letters of the word jewelry in which the 3 E's are together and the 2 L's are together. So how many letters are we talking about? We're talking about 9 letters. So let's start by making 9 blacks. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, since we are supposed to keep the 3 E's together, let's put them in a box. So 3 E's goes inside a box. Whenever you're supposed to keep a certain number of letters or a certain number of people together, you always put them in a box. And since you're also supposed to keep 2 L's together, you keep the 2 L's in a box also. Okay, so 3 factorial, divide by 3 factorial because they're identical. 2 factorial for the 2 L's, divide by 2 factorial because they're identical as well. Okay, now what are we left with? We're left with 1, 2, 3, 4, 5, 6. 6 units. So what's that equal to? That's equal to 6 factorial. Now, whether or not you do 3 factorial divide by 3 factorial into 2 factorial divide by 2 factorial does not make a difference, but it's a good habit so that you know exactly what's going on. Okay, so that if you're not doing it, you know exactly why you're not doing it. Okay, so what's the answer? The answer is 6 factorial, which is equal to 720. Okay, part B. Part B says find the number of different arrangements. Acha, beta, maine kaha na ke I'm doing a bunch of questions. This will be a lengthy stream, so I would appreciate you be patient. Otherwise, I'll have to hide you from the channel. Please don't make me do that. Okay? We'll do those questions as well. Find the number of different arrangements that can be made from the 9 letters of the word jewelry in which the 2 L's are not next to each other. Okay, so once again, question very similar to the question that we have solved. The 2 L's are not next to each other. So not next to each other. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is from May, June 2020, paper 5, variant 1. So first let's find out the number of ways that the 2 L's are together and we'll subtract that from the total. So L's, whenever you have 2 objects and you're supposed to find out the number of ways they're not together, you first find out the number of ways they are together, subtract it from the total, and that's your answer. Simple as that. So L's together, let's see what's that. Let's put them in a box. There you go. Okay, so in this box, there's 2 factorial, divide by 2 factorial. What's happening outside? 1, 2, 3, 4, 5, 6, 7, 8. So 8 factorial. Don't forget that there are 3 E's in the remaining letters. Okay, so you have to divide by 3 factorial also. So 8 factorial divided by 3 factorial, what's that equal to? That's equal to 6,720. Okay, so this is the number of ways that L's are together. Now let's find out the total, because I think in the previous part we did not find the total. We just found out the number of ways that E's are together and the 2 L's are together. So the total would be equal to, how many letters do we have? 9 factorial. From the 9 letters, there are 2 L's, so that's 2 factorial, and there are 3 E's, so that's 3 factorial. Is there any other way to do this? What's wrong with this method, Pata? Okay, if you're looking for a shortcut, if you're looking for a formula, then there isn't any. You have to use your common sense. So 30,240. Okay, so let's see what do we get. 30,240 minus 6,720. Let's see what's that equal to. 6720. That's equal to 23,520. Okay, there you go. No. So what's the star method? I'm sure you yaqinan sir Zain ne koi na koi naam diya hoga, but you'll have to explain to me what's the star method. All right, let's do another question. Let's do this. Question number 5. Dekho, if there's a method that you guys use and you're comfortable with that, go ahead, use that method. Simple as that. Okay. If there's a method that you guys are comfortable with, then go ahead and use that. Okay. Why didn't we choose 2C1 when taking 1L? We do that when we're doing probability. Okay, we do that when we're doing probability. Okay. Now, in a competition, there are 8 pianists, 4 guitarists, and 6 violinists. 7 of these musicians will be selected to go through the final. How many different selections of the 7 finalists can be made if there must be at least 2 pianists, at least 1 guitarist, and more violinists than guitarists? Okay, so that means how many marks is this? A 4-mark question. So we have to basically come up with all the possible arrangements there may be. Okay, so we have to list all possible arrangements there can be before we can solve this question. Okay, so here's what we can do. Let's make a column for P. Remember that there are 8 P's. Okay, and there are 4 G's. Okay, and there are 6 V's. Okay, so there are 4 guitarists, and there are 6 violinists. All right, yeah, so let's make all the possible combinations. And remember, the total must be equal to 7. Okay, total must be equal to 7. So there has to be at least 2, so let's start with that. Okay, let's keep this fixed at 2. Okay, let's keep this fixed at 2 for as long as we can, and let's change this, and then we'll start increasing the number of pianists. Okay, so if let's say I keep 1 guitarist, then remember the number of violinists must be more than the number of guitarists. So that means I must have 4 violinists so that the total is equal to what? So that the total is equal to 7. Okay, now once again, let's keep this fixed at 2. So if I keep 2 pianists and if I keep 2 guitarists, that means now altogether I have 4 people. Now I must have total of 7 and the number of violinists must be more than the number of guitarists. That means I gotta have 3 violinists. Now I can't keep this fixed at 2 anymore, because if I keep this fixed at 2, this will be 3 and this will be 4, which is obviously not possible. Okay, so how about we increase the number of pianists? Let's bring this up to 3. So if I bring this up to 3 and if I keep 1 guitarist, that means I must have 3 violinists. That way the total will be equal to 7. Similarly, so I can't have this 3, 2, because then I will have to bring this up to 3. That's not possible. The total will exceed by 7. So how about if I have 4 pianists, okay, and I have 1 guitarist. So we have 5 people now. We want to make a total of 7. So that means I got to have 2 violinists. There you go. Okay. Let's see if we've missed anything. No, we haven't. We can't have 5, 1, 1 because we got to have more violinists than guitarists. Okay. Okay. Sir, no, we have 2 pianists, 1 guitarist, 3 violinists. 2 pianists, 1 guitarist, and 3. Beta, wo to total 6 ho jayega na? Read the question. Once again, you guys are not reading the question. If we have 2 pianists, 1 guitarist, and 3 violinists, that will make a total of 6. We can't have a total of 6. We got to have a total of 7. This, by the way, is May, June 2020, paper 5, variant 1. Okay. Now, how can we select 2 from 8? That's 8C2. How can we select 1 from 4? That's 4C1. 4 from 6? That's 6C4. Okay. 3, 1, 3 can't be possible as V must be greater than P. Yeah, that's not possible. No, V must not be greater than P. V must be greater than G. 3, 1, 3 is... Okay, why didn't we consider 3, 1, 3? No, we did consider 3, 1, 3. Yeah. Okay, now. 8C2, please read the question. Okay, read the question. 8C2 into 4C2 into 6C3. There you go. Then 8C3 into 4C1 into 6C3. There you go. Then 8C4 into 4C1 into 6C2. Okay, so let's work this out. Yeah, we will add every... So basically, this is one team. Okay, so this is one team. So we'll find out the number of ways that you can make this team. Then this is another team. So this will be separate. This will be separate. This will be separate. Okay, so these are different ways of selecting 7 people. It's this or this. Whenever there is or... Okay, or whenever there are multiple ways of explaining Achieving the same condition, we add the number of ways. Simple as that. So 8C2 into 4C1 into 6C4, that's equal to 1680. So 1680. Then 8C2 into 4C2 into 6C3, that's equal to 3360. Okay. Then 8C3 into 4C1 into 6C3, that's equal to 4480. Okay. Then finally 8C4 into 4C1, which is 4 into 6C2. So that's equal to 4200. Okay, let's add them up. 4200 plus 4480 plus 3360 plus 1680. That's equal to 13720. Okay, 13720. There you go. I'm making it seem harder? Well, then don't watch it. Simple as that. Why didn't we consider all of them? Usually it would be considering the violins only. What do you mean? What do you mean? Read the question. I don't think you guys are reading the question. The question says that you got to have at least 2 pianists. Okay, that means could be 2 or more than 2. All right, and the at least 1 guitarist. Okay, so that means could be 1 or more than 1, and the number of violinists has to be more than the number of guitarists. So there's no formula to it. There's no trick to it. You have to list all the possible combinations first, and then you find out the number of ways this can be done. It's simple as that. So what we do is we keep the pianist fixed at 2 and we select 1 guitarist. Now remember, the rule is that you have to make a team of 7. Okay, you have to make a team of 7. And the other rule is that you have to have more violinists than guitarists. Okay, so how do you make this total 7 while making sure that the number of violinists is more than the number of guitarists? You have to select 4 violinists so that the total is equal to 7. Simple as that. Now, let's keep the pianist fixed at 2. If I increase the guitarist, so we have 2 guitarists now. And once again, you have to make sure that the total is 7 and the number of violinists is more than the number of guitarists. Okay? Now, if I increase the number of pianists to 3 and we select 1 guitarist, once again, we have to make sure that the total is 7 and the number of violinists is greater than the number of guitarists. Okay, so this has to be always greater. Always greater. Okay, so there you go. 313 is one way. Then let's say that we have 4 pianists. Then we have 1 guitarist. That's possible. And what about the number of violinists? So you have to make sure that the number of violinists that you add make the total 7 and they're always greater than the number of guitarists. So you can have 2 violinists. There you go. Yeah, there will be a mock tomorrow, inshallah. And this is from May, June 2020, paper 5, variant 1. Okay, अब इसका कोई shortcut नहीं है. If you're looking for a shortcut, and this is, by the way, this is actually a much easier question. Okay, so I don't think you guys have solved past papers yet. So which is why this is coming as a surprise to you guys. When you solve past papers, you'll realize how difficult questions are. And we will come across a question where there are like 7, 8 possible lists that we have to consider. You know, 7, 8 different possible combinations that we have to consider. So considering that, this is actually very easy. No, there is no way to find the total outcomes. Okay? So you have to think. There's no shortcut. There's no shortcut for everything. Okay? Okay, let's do a difficult question. And then after that, I'll do probability. हाँ, crocodile वाला भी question करूँगा, don't worry. Okay, I'll do a... Oh wow, क्या बात कही है भाई. How long will this stream be? As long as it takes. As long as it takes for me to solve 20-25 questions. Okay, that's very nice of you to say that. Okay, hang on, let me take a picture of it. हाँ, crocodile वाला question भी करेंगे, don't worry about it. Yes, I'm aware, ceasefire done. I don't live under a rock. I'm aware, ceasefire हो गई है. Okay, let's solve this question. Find the number of different ways in which the 10 letters of the word summertime can be arranged so that there is an E at the beginning and there is an E at the end. Andromeda वाला भी करेंगे, yes. Andromeda वाला भी करेंगे, Casablanca वाला भी करेंगे, Crocodile वाला भी करेंगे. ठीक है? बस आप लोग ज़रा चिल होके बैठें. ठीक है? एक चीज़ से दूसरी चीज़ पर छलांग ना लगाएं. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So there is an E at the beginning and there is an E at the end. Okay. All right. Now, so the restriction, we've settled the restriction. Now we don't have to worry about anything else. And by the way, if I swap the E's, will that make it a different arrangement? No, because they're identical. Okay, so it will not make a different arrangement. It will remain the same arrangement. Okay. So once we settle the E's, how many letters are we down to? We're down to 8 letters. Okay, so that means 8 factorial. Okay. Now don't forget that while we've dealt with the E's, there are some other repetitions to take care of. So for example, there are 1, 2, 3 M's. Any other letter that's repeating? No. S comes once, U comes once, R comes once, T, I, they all come once. So that means we divided by 3 factorial. And that's it. 8 factorial divided by 3 factorial. You know, the majority of the permutation combination questions are easy. There's always that one tricky part due to which you guys say that the entire chapter is difficult. That's not the case. There's always like a certain part of a question that's difficult. Okay, now part 2. Find the number of different ways in which the 10 letters of the word summertime can be arranged so that the E's are not together. Once again, so this is something that we're going to be dealing with very often. So let's find out the total. We've already done. No, we haven't done that. So let's find out the total. ठीक है, हमेशा ना total पहले निकाल लिया करो because total is easy. So you will get some marks out of it. Okay, especially in probability or especially in questions like these, it's always a good idea to find out the total first. So how many letters are we dealing with? We're dealing with 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that would be 10 factorial. And don't forget that amongst these 10 letters, 1, 2, 3, M occurs 3 times, so that's 3 factorial. E occurs twice, so that's 2 factorial. Let's see what's that equal to. So 10 factorial in the numerator, divide by 3 factorial into 2 factorial. What's that equal to? That's equal to 302,400. 302,400. Okay, let's hold on to that. Now let's find out the number of ways that E's are together. Okay, how do you make sure that the E's are together? Let's use these. How many E's are there? There are 2 E's. Let's put the E's in a box. Okay, there you go. E's in a box. 2 factorial, divide by 2 factorial. 2 factorial, divide by 2 factorial. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So into 9 factorial, don't forget that in the remaining letters there are 3 M's. So we divided by 3 factorial. Okay, so what's that equal to? Let's have a look. 9 factorial divided by 3 factorial, that's equal to 60,480. So total minus E's together will give you the number of ways that E's are not together. So 302,400 minus 60,480. So 302,400 minus answer, that's equal to 241,920. There you go. ठीक हो गया. So pretty standard way of solving questions like these. Sir, can we solve a question with arrangement where we need to... Yeah, we'll do that. We'll do that. So would you give a break after some time? Achha, I don't know what is the star method that you guys are talking about. ठीक है. So 4 letters are selected at random from the 10 letters. Now we're talking about selection, but we're not talking about probability. Okay, we're talking about selection, but we're not talking about probability. Now we will not multiply by 2 in part A because the E's are identical. Okay, so if I swap this E with this E, will you notice the difference? No, you won't. Why? Because they're identical. So that's why you will not multiply by 2 factorial. Okay. All right, 4 letters are selected from the 10 letters of the word summertime. Find the number of different selections if the 4 letters include at least 1 M and exactly 1 E. Okay, at least 1 M and exactly 1 E. So what we're going to do is, so what's the variable condition and what's the fixed condition? So this is the fixed condition and this is the variable condition. Okay, so let's write the fixed condition first, that is 1 E. Okay, and the variable condition, at least 1 M means 1 M. Let's start with 1 M. Okay, and how many letters are we selecting? We're selecting 4 letters. So 1, 2, 3, 4. Okay, So 1E is already selected, 1M is already selected. Okay, we don't have to consider repetitions here because this is not probability. We'll do a probability question, then you'll find out how we do it, and also you'll find out why we consider repetitions there. ठीक हो गया? Okay, so we're talking about summertime. And we have to make sure that we have only one E and one M. So that means we can cross out all the M so we don't end up selecting them again. We can cross out all the E so that we don't end up selecting any other E. So how many letters are we down to? We're down to 1, 2, 3, 4, 5. We're down to 5 letters and we have to select 2 of them. So that's 5C2. What's that equal to? That's equal to 10. Okay. Now, 1E is fixed. We can't change that. But let's select 2 M's. So 1, 2, 3, 4. 1E is fixed, but we can increase the number of M's. Now, once again, after doing this, we'll be down to 5 letters. So that would be 5C1, which is equal to what? Which is equal to 5. Okay. Achha, also, considering that we have 3 M's, that means we can also do this. We can have 1E and we can have 3 M's. Okay. So if I select 1E and 3 M's, that means I don't have to select anything. 1E and 3 M's. That means we still have 5 letters, but I don't have to select anything. So that's 5C0. What's that equal to? That's equal to 1. So altogether, that's 10 plus 5 plus 1, which is equal to what? Which is equal to 16. Okay, now I'll have a look at your questions. Sir, in the normal distribution stream, have you covered all questions? But just watch the stream and find out. Okay? No need to spam, just watch the stream and find out. You think it's 25? Did I miss a condition? No, I don't think I missed a condition. This is the answer. Okay. अच्छा ज़ैना बेटा ये हम करते हैं probability में, ठीक है? ये जो 2C1 और 3C1 हम करते हैं probability में, ठीक है? Why didn't we multiply by factorial? Because we're talking about selections. We're talking about selections, so we'll have to take combination. Okay. अच्छा, what other question? 1E and 2M can be write as 1C1 and 2C2. Yeah, you can do that. You can do that. Yeah, you'll have a mock tomorrow. Don't worry about it. Beta, मैं threshold नहीं set करता, so I can't tell you how many marks, but you should aim for 45. In part B, can we do? But I don't know what the star method is that you guys are talking about. Okay, so please stop bothering me with that. अगर आपने कोई और method सीखा है, जिस भी teacher का method है, if you're comfortable with it, then please stick to it. ठीक है? But ये नहीं कि आप half baked वो method सीख लें, half baked मेरा method सीख लें, and then you ना इधर के ना उधर के, ठीक है? So no, you can't do 2C1 for E and 2C1 for M. That is for probability. Okay? Now I don't know how many times I've said that already. That is for कैसे लोग हैं आप लोग यार, सुनते ही नहीं हैं. अच्छा, let's do another question. बेटा मैं ऑन द सेफ साइड बता रहा हूँ 45, ताकि वो दोबारा मुझसे ये सवाल ना पूछे. ओके, चलें आगे चलते हैं. लेट्स डू अनदर क्वेश्चन. अब एक काम करते हैं, अब ज़रा ना मैं एक प्रोबेबिलिटी का क्वेश्चन करा ही देता हूँ ताकि आप लोग मेरा दिमाग खाना बंद करें. Okay, why don't we do this? Why don't we do that? चलें वो एंड्रोमेडा वाला क्वेश्चन करते हैं. Okay. Yeah, wait a minute. We will do this question. पहले ज़रा there we go. Let's do this question. Find the number of different arrangements of the 9 letters in the word Andromeda in which no consonant is next to another consonant. Okay. And yeah, अच्छा, अब in case किसी को नहीं पता कि कॉन्सोनेंट क्या होता है, यहाँ पे लिखा हुआ है, ठीक है. Alright, now here's what we're going to do. How many letters do we have? We have 9 letters, okay? And how many consonants do we have? We have 5 consonants, okay? And we have 4 vowels. So 5 consonants and we have 4 vowels. Okay, so C, 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 and C. Yep, 5 consonants and 1, 2, 3, 4 vowels. Okay, now if you have to make sure that there is no consonant next to another consonant, then that means, no, there are 5 consonants. Okay. I mean 5 in total, yes, but 4 unique. I get what you're saying. Okay. I get what you're saying. Okay, there are 4 consonants. Total 5 हैं, ठीक है, जिसमें से 4 unique हैं. Okay. So the only way that this can happen, remember that there are 9 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now there are two ways that we can work this out. Okay, so here is method 1. So this is what method 1 says. If you have to make sure that no consonant is next to another consonant, that means you got to have a vowel in between. Okay, so if I start with a consonant, that means there's got to be a vowel, then a consonant again, then a vowel, then a consonant, then a vowel, then a consonant, then a vowel, and then a consonant. Okay, now this is question number 34 of the file, and this is from October-November 2023, paper 5, variant 2. ठीक हो गया? Okay, now as far as the vowels are concerned, since there are, as far as the consonants are concerned, since there are 5 consonants, so that means we're going to do 5 factorial. Okay, and then as far as the vowels are concerned, we're going to do 4 factorial. Okay, but be careful that there are some repetitions. Okay, the letter D occurs twice, so that would be 2 factorial, and the letter A also occurs twice, so that means we'll divide by 2 factorial as well. Okay, so what's this 5 factorial for? This 5 factorial is for 5 consonants. Okay, मैं इसको CONS लिख देता हूँ बस. Okay, so this 5 factorial is for 5 consonants. This 2 factorial that you're looking at is basically for the 2 Ds that we have. This 4 factorial that you're looking at, this is basically for the 4 vowels. Okay, and this 2 factorial that you're looking at, this is basically for the 2 A's that we have. There you go. Okay. Acha, up, can we take vowels first? Is it possible that instead of taking consonants first, we take vowels first? What do you guys think? You think it's possible that instead of taking consonant first, I take vowel first? Let's see. Is that possible? We, see, we, see, we, see, we, see, we. No. Why is this not possible? Because as per this arrangement, we have 1, 2, 3, 4, 5. This means that we have 5 vowels, which we don't. Okay, we don't have 5 vowels. Okay, so अगर हम vowel को start में लेते हैं and then we put a consonant after every vowel and we do an alternate arrangement, this can only be possible if there are 5 vowels, okay, and there are 4 consonants, which is obviously not the case. Okay, which is obviously not the case. Okay. Now, what's the second method? Here's the second method. Okay, here's the second method. So what's the answer? First, let's work out the answer. So 5 factorial into 4 factorial divided by 2 factorial into 2 factorial. So that's 2 times 2, which is equal to 720. ठीक हो गया? Okay, 720 is the final answer. Now, what's the second method? Now, pay close attention to the second method. Here's how this works. For the second method, who has a problem and who doesn't? Thank you, I appreciate that. So basically, it's the consonants that have a problem, right? They can't be next to each other. So vowels ko koi masla nahi hai. If they're next to each other or if they're not next to each other, they don't have anything to worry about. So what we're going to do is we're going to exclude the ones that have a problem and they can't be next to each other, and we're going to focus on the ones that don't have a problem and can be next to each other, and that's basically vowels. Okay, so first we will fit all the vowels. 1, 2, 3, 4. Okay, so how many vowels are there? There are 4 vowels. Now, if a consonant cannot be next to another consonant, that means we can only place the consonants in between the vowels. That means we can place a consonant here, 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 or we can place a consonant here. Okay, so remember, these are vowels. Vowels, 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 vowels. Okay? So we can have a consonant here, 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 or we can have a consonant here. Okay? Acha, this is the star method. Why is this called the star method? I'd like to know. Yeah, chalo, I'll just ask Sir why he calls it the star method. Anyway, so if we focus on the consonants, so this is for consonant, this is for consonant, 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 consonant. Okay. Now, how many places do we have for each for consonants? We have 5 places. And how many consonants do we have? We have 5 consonants also. So that's 5p5. ठीक है. Acha. Then what should I multiply this with? I multiply this by 4 factorial. Why? Because of the 4 vowels. And don't forget that 4 vowels के बीच में, ठीक है, amongst the 4 vowels, there are 2 letters that are repeating, so 2 factorial. And also do not forget that amongst the 5 consonants, there are 2 letters that are repeating, so we divide by 2 factorial. There you go. Okay, Sir Zain calls it a star method. Why does he call it a star method? चलें आप लोग ही बता दें. Into 4 factorial divide by 2, so you'll get the exact same answer. Okay, so this is the gap method and the star method. Funny नहीं है. Khair. What method you want to call it, that's up to you. Okay. Acha, that's it. Chale, so I'm going to call it the line method now. Kya khayal hai? Because he places stars as the lines / gaps. ठीक है, so I'm going to call it the star method. Modulus method? Nah, I don't like modulus. People will get confused. All right, now part B. Let's see what part B says. Find the number of different arrangements of the 9 letters in the word Andromeda in which there is an A at each end and the D's are not together. Okay, so once again, we're circling back to the very first question that we solved. Okay, this is the very first question that we solved. There are 2 conditions. A at each end, so that this is a non-negotiable condition. And the D's are not together. So what we can do is we can change that. Okay, we can keep the D's together while keeping the A at each end and subtract that from the total number of ways there is an A at each end, and we will have the number of ways there's an A at each end and the D's are not together. So why are you doing my question? What do you mean, why are you doing? Why are you doing my question? What do you mean? Have you bought rights to this question? I don't understand what you mean by that. Okay, so anyway, there are 9 letters. So let's start with that. 1, 2, 3, 4, 5, 6, 7, 8, 9. ठीक हो गया? Okay, there is an A at each end. So let's start by placing the A's at each end. And the D's are not together. Okay, so how about we keep the D's together? Okay, so we keep the A at each end and we keep the D's together. So if I keep the D's together, let's put them in a box so they can shuffle amongst themselves. So that would be 2 factorial divided by 2 factorial into 1, 2, 3, 4, 5, 6. So 2 factorial divided by 2 factorial, which is honestly useless, but the reason why I do it is because when we're dealing with people, this is not useless because people are different, letters are same. So it's a good idea to get into this the habit of doing this. So into 6 factorial. Actually, don't forget that there are some repetitions to consider. No. D ही repeat हो रहे थे और A repeat हो रहे थे, so there is no repetition to consider. So that's it, 6 factorial. 6 factorial, what's that equal to? That's equal to 720. Yeah, I was just going to answer that question, but thank you for doing that on my behalf. No, I don't teach in Nixer O levels. I left a long time ago. It's been not a long time ago. It's been, I think this is my 3rd year or 2nd year of doing online entirely. So what we have done right now is basically A at each end and D's together. Okay, A at each end and D's together. So why do we not include the A's on ends? So if you're asking me why we don't multiply by 2 factorial, because if I swap the two A's, it's the same thing. Okay. So I used to watch your admin stream and you taught an Excel. So that must be last year or last year. Here. Now let's find out the number of ways that we can have A at each end and D's not together. अच्छा एक और method है, ठीक है, एक और method है, but I wouldn't recommend that. I would recommend this method honestly. Okay, it's much simpler. It's lengthy, but it's much simpler. So A at each end and the D's are no wait. हमने total निकाला हुआ है? नहीं, हमने total नहीं निकाला हुआ. ठीक है. तो एक काम करते हैं, पहले total निकाल लेते हैं. ठीक है. So A at each end and D's together. Let's find out the total, which means A at each end. We haven't done that. No, we haven't. So how can you have A at each end? Let's work that out. Let's start by making 11 blanks. There you go. Achha, isko mita dete hain. So A is at each end. That's the condition that we cannot change. Okay, so we can't change this condition. So how many letters are we left with? We're left with 1, 2, 3, 4, 5, 6, 7. So that means in between there's 7 factorial. And don't forget that amongst these 7 letters, there are 2 D's. So we'll divide by 2 factorial also. Okay, so 7 factorial divided by 2 factorial, that's equal to 2520. So this is equal to 2520. Okay, so A at each end and D is not together. That would be equal to 7 for 2520 minus 720. Let's see what do we get. 2520 minus 720. That's equal to 1800. There you go. Okay, acha. These were all easy parts. So 3 plus 3, that's 6 easy marks. Now this is the reason why I chose to solve this question is because of this. Okay. Now, all right. Can you do this by NCR method? What NCR method? This is not combination. So NCR is combination. We use it when we're selecting. So we can't do that. Sir, can you do a question where it says that the letters should be together, but the number of letters together can vary? So I do plan on solving lots and lots of questions tonight. So I would appreciate if you guys are just a little patient. So I will probably end up solving a question. I will probably end up solving a question like that. Okay. Now here we are talking about probability. Find the probability. Okay, so very important note before I start. A very, very important note before we solve this question note. In combination questions dealing with probability, repetition is to be considered. Okay, which basically, now what does this mean? This means that how many ways can you select one A from 2 A's? इसका क्या आंसर होगा? इसका आंसर होगा 2C1. Okay, so how many ways can you select one A from 2 A's? इसका आंसर होगा 2C1. Okay, so the answer to this would be 2C1. Okay, which is equal to 2. All right. Now the question is, why is it equal to 2C1? Okay, why do we consider repetition? Let's understand that. Okay. So, for example, मुझे यहाँ पे किसी का कोई नाम देखता हूँ जिसमें repetitions हो रही हों. किसी का नाम Zaina, Zaina. ठीक है. Okay. अब अगर मैं आपसे पूछूं कि what's the probability of selecting an A here? Okay, so if I ask you what's the probability of selecting an A, what are you going to do? If I ask you guys what's the probability of selecting an A, so are we just going to say 1A divided by the total? No. What is the total first of all? The total is 5. 1, 2, 3, 4, 5. Okay. Now, since we're talking about probability, I cannot say 1 upon 5. That's wrong. Okay, I cannot say 1 upon 5. That's wrong. Because there are two A's, so the probability of selecting an A, since we're talking about probability, that means I have to count all the possible A's as favorable outcomes. Okay, because we're talking about probability, I have to count all the ways as possible outcomes. So that's 2 upon 5. Okay, now how would you do this using combination? You would do this using combination by doing 2C1 because there are two A's and you want to select one. So that's 2C1. Okay, and how many ways can you select a letter? So that would be 5C1. So what's that equal to? That's equal to 2 upon 5. This is the reason why you basically consider repetition when we are doing probability. Okay, so I hope that's clear. Now with that, we still have plenty of space. Let's solve this question. So it says find the probability that this selection contains at least one D and exactly one A. Okay, so in selections, okay, when we have to just list number of different selections, we don't consider repetitions, but when we're talking about probability, repetition is to be considered. Okay, simple as that. ठीक है, अब अगर आपको इसके पीछे logic समझ आ गई, very good. अगर नहीं समझ आई, nothing to worry about. Just remember this rule. Okay, just remember this rule. That in combination, questions dealing with probability, repetition is to be considered. So if there are two A's and you want to find out the probability of selecting one, you will do 2C1, simple as that. Okay? Or how many ways can you select one A from two A's, or what's the probability? You will do 2C1. Okay? Simple as that. All right. Now, let's answer this question. It says find the probability that this selection contains at least one D and exactly one A. Now remember, this is fixed. Okay, exactly one A, that's fixed, and this is variable. At least one D means that it could be one, it could be two. I don't think it's more than one. Yeah, so we can't change that. So here's what we're gonna do. Let's start with 1A since that's fixed. We can't change that. So let's start with 1A and at least 1D. So let's start with 1. Okay, how many letters are we selecting? We're selecting 4 letters. So we make 4 blanks. 1, 2, 3, 4. So how many ways can you select 1A and 1D? Let's see. Remember, we're talking about probability. अच्छा, अब before we do this, मेरा आपको एक मशवरा है कि if you want to secure some marks, immediately find out the total first. Okay, immediately find out the total first. कैसे निकालेंगे total? So we are selecting 4 from the 9 letters because once you find out the total, even if let's say you get the favorable, even if let's say you get the favorable outcomes wrong, you still end up getting some marks. So the total would be equal to 9C4. Why? Because there are 9 in total, okay, and there are 4 that you have to select. So 9C4, let's work that out. 9C4, that's equal to 126. Okay, there you go. Now, how many ways can you select 1A and 1D? Now remember, there are 2 A's. Okay, in this letter, there are 2 A's. So since we're talking about probability, we have to take into account the repetitions. We can't just consider it as, consider the 2 A's as same. We have to consider them as 2 letters. So how many ways can you select 1A from 2? So that's 2C1. Okay, so this is basically for the A. Then for the D's, how many D's do we have? We have 2 and we have to select 1, so that's 2C1. Okay, now once you ignore the A's and the D's, what are you left with? You're down to 1, 2, 3, 4, 5 letters, and you have to select how many? You have to select 2, so that would be 5C2. Okay, 5C2, what's that equal to? नहीं, we want, बेटा अभी तो हमने कहा ना कि जब भी हम probability कर रहे होते हैं तो हम 2 factorial से divide, हम factorial को कहीं consider करते ही नहीं हैं. Okay, whenever we are doing probability, see what's factorial for? Factorial is for repetition. Okay, when we're talking about probability or when we're talking about arrangement, we're not dealing with repetitions. So when we're talking about combinations, we're not dealing with repetitions. Okay, so 2C1 into 2C1 into 5C2, let's see what's that equal to. 2C1 is 2, 2C1 is also 2 into 5C2, which I believe is 10, but let's do it anyway. So this is equal to what? This is equal to 40. Okay, now remember 1A is fixed. We can't change that. Okay, so this is fixed and this can vary. So let's increase 1D to 2. So 1, 2, 3, 4. So 1A and 2Ds. Now how many ways can you select 1A from the 2 A's that you have? So that's 2C1. How many ways can you select 2Ds? So that's 2C2. And now you're down to how many letters? You're down to 5 letters and you have to select just one. So that's 5C1. So that means 2C1 into 5C1. What's that equal to? That's equal to 10. Okay, any other possibility? No, there isn't. There is no other possibility. Okay, so that's it. 40 plus 10, what's that equal to? That's equal to 50. And this is question number 34 from the worksheet. अच्छा बेटा crocodile वाला भी करते हैं ज़रा, ठीक है? आपको जल्दी है तो आप बाद में recording देख लीजिएगा, ठीक है? But I want to do some more probability questions before I jump to that. AdMaths, I did a stream of AdMaths today at when did I do it? At 2 p.m. vectors, and I'll announce on my Instagram. Whenever I'm doing a stream, I'll announce on my Instagram, so you can check it then. Simple. अच्छा ब्रेक अभी लेते हैं ज़रा. अच्छा डोंट फॉरगेट कि हमें probability निकालनी थी, ठीक है? We had to take out probability. So 50 upon 126, what's that equal to? 50 divided by 126, that's equal to 25 upon 63. Okay, so this is the favorable and this is the probability. There you go. Yeah, I will be doing more S1 streams. There will be a mock inshallah tomorrow. And after that, I think I'll probably be doing another stream on permutations and combinations. Let me do some more probability related questions. Then after that, we'll take a break. I need to pray Asr. I haven't prayed Asr. Okay, there you go. Here is another. Yeah, P3 streams most likely either starting from tomorrow or starting from Monday. Okay. So let's solve this question. This also has the probability part in it. Let's see what it says. Find the number of different arrangements of the 9 letters in the word activated. So sometimes these type of questions say selection, sometimes it says no, there is no difference. This is from October-November 2022, paper 5, variant 3. Okay, and this is question number 24 of this worksheet. Okay, so find the number of different arrangements of the 9 letters in the word activated. So that's pretty straightforward. 9 factorial, anything being repeated, TIC being repeated. I think that's about it. 9 factorial divided by 2 factorial for the T's, A factor or 2 factorial for the 2 A's, 1A, 2A, 1T, 2T. That's it. Yeah, I do live in Karachi. Kyun bhai? So that's equal to 90,720. Okay. Now, let's see what's next. Find the number of different arrangements of the 9 letters in the word activated where there are at least 5 letters between the 2 A's. Okay. So I think the examiner, while making this question, was probably thought to himself or herself that how can we make this question more difficult? And they made it more difficult by adding the word at least. Because if the question was that there are 5 letters between the 2 A's, this would have been a fairly easy question. But the fact that they said at least, so maybe this was what they came up with initially, and then somebody was like, no, let's make it more difficult. So they decided to add the word at least in between. Okay. But anyway, even then, it's not like an impossible question. It's still doable. So at least 5 means that it could be 5, could be 6, could be 7. Okay, at least 5 letters basically means that it could be 5, it could be 6, it could be 7. Simple as that. Okay, so let's start with 5 letters. So if there are 5 letters between the two A's, how does that work? So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, here's an A. Okay, now if there are 5 letters in between, so that means 1, 2, 3, 4, 5, and then there's another A. Okay, so there's an A here. All right. Now, there are 7 letters. 1, 2, 3, 4, 5, 6, 7. So if there are 7 letters, that means there's got to be 7 factorial to take into account how many ways they can shuffle amongst themselves. Okay, and then divide by 2 factorial to take into account the repetitions. So what are the repetitions? If we ignore the A's, there are 2 T's, so that's 2 factorial. But here's the thing. The question said that there has to be 5 letters in between, so that means these 2 A's can jump. Okay, so you can have the 2 A's here. Okay, or you can have the 2 A's here. So that means there are 3 ways that you can have the 2 A's with 5 letters in between. So that's 1, 2, and 3. Okay, so what are we going to do now? We're going to multiply it by 3. Okay, not 3 factorial. Okay, because we're just talking about how many different places you can have the 2 A's with the 5 letters in between. So we'll multiply it by 3. Okay, so we'll multiply it by 3, whatever that is equal to. If someone can work, yeah, chalo, I'll just work this out. So basically 7 factorial. Beta, aapko isse kya meri shaadi hoyi ho ya na hoyi ho? Why are you asking? I'm curious. 7 factorial divided by 2 factorial into 3. What's that equal to? That's equal to 7,560. Okay. Now, please, advanced students, don't watch this. Okay, you guys will probably go into depression. Okay, so I'm warning you guys not to watch this. Because the kind of permutations and combinations that we have in AdMaths is a piece of cake compared to this. So please don't watch this. This is not the kind of questions you will have. Okay, now. What if we have 6 letters in between? Okay, what if I have 6 letters in between? So that way, once again, 1, 2, 3, 4, 5, 6, 7, 7 factorial. Okay, for the remaining 7 letters, divide by 2 factorial to take into account the repetitions. Okay, and with 6 letters in between the 2 A's, you can have the 2 A's in 2 places. 1 and 2. Okay, so we'll multiply it by 2. Okay, so what's that equal to? That's basically as good as 7 factorial. 7 factorial, that's equal to 5,040. Okay, now what if we have 7 letters in between? 7 letters. That's also possible, right? Because the question said at least 5. So with 7 letters in between, this is what that looks like. Now there's only one way that you can have 7 letters in between. Okay, and with 7 letters in between, that would be 7 factorial divided by 2 factorial. So 7 factorial divided by 2 factorial, what's that equal to? 7 factorial divided by 2 factorial, that's equal to 2520. Now what's the total? The total would be equal to 2520 plus, this. Okay. Plus this. Plus this. ठीक है, इन तीनों को ऐड कर लो. That's going to be your total. Let's see what's that. 2520 plus 5040 plus 7560. So that's equal to 15,120. Okay. Pray for what, beta? 15,120. There you go. So why not 7p5 for 5 words in between? Okay, if you do 7p5, ultimately you will have to do 2 factorial anyway. So बात एक ही हो जाएगी. आप 7p5 करो और फिर उसके बाद you do 2 factorial, it's the same thing. Okay, so 7p5 is what? 7p5 is 7 into 6, 7 into 6 into 5 into 4 into 3. Okay, and then for the remaining 2 places, you'll do 2 factorial. So what's that as good as? That's as good as 7 factorial. Okay. Alright, ये सवाल पूरा कर लेते हैं फिर I'll give a namaz break. ठीक है. So 5 letters are selected at random from the 9 letters in the word activated. इसके बाद I'll give you guys a namaz break. ठीक है. Find the probability. So how do we know when we do 3 and not 3 factorial? Okay, that's a good question. So 3 factorial is when you are shuffling 3 different things. Okay, that's when you do 3 factorial. 3, we multiply by 3 when there is one condition which can be achieved in 3 different ways. So we multiply it by 3. So that means the condition here was that the A's have to have 5 letters वाली combination कहाँ गई? अच्छा खुद से चीज़ें मिटने लगी हैं वाह भाई. अच्छा. So basically reason why I multiplied by 3 here is because you can have the 2 A's with 5 letters in between in 3 different places. That's why we multiplied by 3. Okay, 3 factorial jab karte when we were shuffling 3 objects, okay, or 3 letters. That's when you multiply by 3 factorial. Okay, now let's quickly solve this question. So this question says, find the probability that the selection, once again, it's probability and it's selection. Okay, so 5 letters selected from the 9. So immediately do one thing and that is find out the total. Okay, ताकि कम से कम एक मार्क तो आपका पक्का हो जाए. 9C5, what's that equal to? Let's see. 9C5, that's equal to 126. ठीक हो गया? Okay, now. The question says, find the probability that the selection does not contain more T's than A's. Okay, does not contain more T's than A's. That means you can have an equal number of T's, you can have an equal number of T's and A's, but you can't have more T's than A's. ठीक है. So let's start with, it's possible to have 0 T's and 0 A. Okay, that's possible. So that means the 5 letters that you're selecting, 1, 2, 3, 4, 5, from the word activated. Okay. Now you have to make sure that you don't select an A and you don't select a T. Okay, so the only way to do that is by first crossing out the A's, crossing out the T's. So what are we left with? We're left with 5 letters, 1, 2, 3, 4, 5. So that means 5C5. And what's that equal to? That's equal to 1. Okay. Now, let's increase the number of A and keep T's at 0. Okay, because we have to make sure that the number of T's are always less than A's. Okay, so let's increase the number of T's. So that's 1 T. And let's keep the number of A's fixed at 0 for as long as we can. Okay, so 1, 2, 3, 4, 5. Okay, so 1 T. Now, how can you select 1 T? You have 2 T's to select from and you have to select 1. So that's 2C1. Okay. Now you have to make sure that you don't end up we have to make sure we don't end up selecting an A. So we've crossed out the A's already. So we're down to 5 letters. So that would be 5C4. 2C1 into 5C4. Now what's this 2C1 for? This is basically for the T and this is for the remaining. So 2C1 into 5C4, let's see what's that equal to? 2C1 into 5C4, that's equal to 10. Okay, now. Then let's talk about, let's increase the number of, अच्छा नहीं wait, मैंने उल्टा कर दिया. हाँ, उल्टा कर दिया. Okay, उल्टा कर दिया. We have to have, does not contain more T than A's. ठीक है, तो हम T's को 0, एक काम करते हैं, does not contain more T's than A's. So let me write it like this. Let me first write A so I can increase the A, 0A and 0T. ठीक है, now let's increase the A, 1A and 0T. अच्छा, surprisingly working इसकी same ही होगी. Okay, working इसकी same ही होगी. ठीक है. Coincidentally, we get away with it. Coincidentally, it does not contain more T than A, so that means they can be equal but not more. Now let's increase the number of A's while keeping the T's at 0. Okay, we can do that. We can increase the number of A's while keeping T's at 0. So if we have 2 A's, so that would be 2C2 multiplied by, now we have 5 remaining letters to choose from, so that's 5C3. Let's see what's that equal to. 2c2 into 5c3, that's equal to 10. ठीक है. Okay, now, अच्छा अब एक काम करते हैं. Let's go back to 1a and increase the number of t's. ठीक है, अब ये आपको सारी सोचनी पड़ेंगी, इसका कोई शॉर्टकट नहीं है. 1a and 1t कर लेते हैं. So 1a and 1t का मतलब है, once again we make 5 blanks, 1 2 3 4 5. एक a आ गया, एक t आ गया. Now how can you select 1a from the 2 a's? So that's 2c1. How can you select 1t from the 2 t's? That's also 2c1. And now the remaining 3 letters will come from the remaining 5. So that's 5c3. So 5c3 is 10. 10 into 4, that's equal to 40. अच्छा और क्या कंडीशन है? और क्या कंडीशन हो सकती है? We increase a t here, 2a and 1t. Yeah, that's possible. 2 A's and 1 T. 1, 2, 3, 4, 5. So 2 A's and 1 T, sir, does it mean? Yeah, it can contain same letters. It means that it can contain same letters. It shouldn't be, the number of T's should not be more than the number of A's. Simple. So 2 A's and 1 T. So that will be 2C2 for the 2 A's, 2C1 for the T, and 5C2 for the remaining letters. So let's see what do we get. 2c2 into 2c1 into 5c2, that's equal to 20. अच्छा अब एक आखिरी condition रह गई है, and that is 2a and 2t, which is possible. Why? Because the question said that you can't have more t's than a's, but you can have equal t's. Okay, sorry, 2a and 2t. a बस दुआ ये है कि आप लोगों को एग्ज़ाम में ये सारी चीज़ें याद रहें with the exam pressure. So that's 2c2 for the 2 a's, that's 2c2 for the 2 t's, and 5c1 for the remaining letter. So that's simply as good as 5c1, so that's equal to 5. Okay, so we have found the favorable outcomes. Let's add them up. So that's 1 plus 10 plus 10 plus 40 plus 20 plus 5. So 1 plus 10 plus 40 plus 20 plus 5, that's equal to 86. Okay, so 86 is the favorable outcome. ठीक है, और टोटल हम पहले ही निकाल चुके हैं, तो एक मार्क तो हमारा गारंटीड आ गया. 86 divided by 126, let's see what's that equal to. That's equal to 43 upon 63. There we go. For 100K, please drop your beard routine. But I told you guys, beard comes with wisdom, so it's going to take a while. Is there questions when we are supposed to use factorial and probability questions? Yeah, of course. If you're talking about arrangements, then you have to use factorial. Okay, if let's say the question is about probability but it's about arrangements, then you have to use factorial. Okay, I'm going to take a break here and we will inshallah reconnect. वैसे if I take a break now, फिर maghrib होगी, फिर we'll take a break again. चलें, let's do that. So I'm going to take a break. ठीक है, फिर maghrib में we'll take another break, no problem. Now, I'll see you guys inshallah in a few minutes. Okay. So here we go. All right. Welcome back. What did I miss? वो एक्चुअली मगरब का टाइम हो गया था तो मैंने कहा मगरब ही हाथ के हाथ ही पढ़ लेते हैं. Maths and Chem the same day. Make sure you guys get a good night's sleep. जिनके भी एक दिन में दो पेपर है ना, get a good night's sleep, man. Very important. Especially S1. Okay? S1, you need a fully functioning brain. If you don't have that, good luck. बेटा मगरिब की अजान हो गई, मैंने नमाज पढ़ ली. ठीक है. That's what took me so long. मैं मगरिब मैंने हाथ के हाथ मगरिब भी पढ़ ली. Okay, 3 papers in a day. How does that work? Beta, I can't wait for everyone. So I'm going to start, फिर आप लोग बाद में देख लेना. ठीक है. Anyway, so we're done with this question. Let's do find the number of different arrangements, the two is and the two L's are together. Find the probability that the two L's together and there are exactly 6 L's, 6 letters between the two is. Okay, let's do that crocodile question. Do I cook? What do you mean by that? Cook what? Crocodile. ये भी अच्छा सवाल है by the way, recorders वाला. Ollie and Petra वाला भी अच्छा सवाल है. This is also a good question. We'll do this also. But right now I'm looking for the... Achha, that came in 2022 if I remember correctly. The crocodile question came in 2022. एक alligator आया, फिर crocodile आया. Yeah, here it is. Okay. Achha, let me tell you something. That if you were to look at the marking scheme of part D, it's wrong. Okay, they later on gave an updated marking scheme in which they had fixed this. ठीक है. बेटा clash होता है तो I think you get like a clash report or something. ठीक है, कुछ बनता है आपका, कोई document बनता है that you have to show. Okay. Find the number of arrangements of the 9 letters in the word crocodile. So 9 letters, easy. 9 factorial. Divided by how many repetitions do we have? 1, 2. So that's 2 factorial for the 2 C's. Then crocodile. 2 O's, I guess that's it. 9 factorial divided by 2 factorial into 2 factorial. Okay, what's that equal to? That's equal to 9 factorial divided by 2 factorial into 2 factorial. That's equal to 90,720. 90,720. Okay. This, by the way, is, in case you're wondering, May, June 2022, paper 5, variant 2. Okay, question number 23 of this worksheet. Okay, now, then the question says, find the number of different arrangements of the 9 letters in the word crocodile in which there is a C at each end and the 2 O's are not together. So once again, you have one non-negotiable condition and one condition which you're going to flip, and then you're going to subtract it from the total. Okay. क्या मैं आपको कॉफ़ी बाय कर दूँ? What do you mean? So let's find out the number of ways in which you have C at each end. Okay, so that means there's a C here, there's a C here. Okay, non-negotiable. Now, and the 2 O's are not together. So we'll talk about that later. First, let's find out the number of ways that you have the 2 C's at each ends. So there are 9 letters in total. If you have 2 C's in the beginning, or 1 at the beginning, 1 at the end, so that means that's 7 factorial. In the denominator, that's 2 factorial for the 2 O's basically. Okay, so 7 factorial divided by 2 factorial, what's that equal to? Let's work it out. 7 factorial divided by 2 factorial, that's equal to 2520. 2520. Okay. Now, so then the question says that the 2 C's are to be at each end and the 2 O's are not together. So let's keep this intact. Let's keep the C at ends and let's keep the O's together. Okay, let's keep the O's together. So if I keep the O's together, so what are we looking at? 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's the C, here's the C. Let's keep the O's together. So that means 2 factorial divided by 2 factorial. And you have 1, 2, 3, 4, 5, 6. So that's basically 2 factorial divided by 2 factorial into 6 factorial. What's that equal to? Let's see. So that's simply as good as 6 factorial. That's equal to 720. Okay, so how can you have C at each end and O's not together? That would be total minus together. Okay, hopefully this concept is now clear to everyone. And this is a very frequently tested question. Let's see what we get. So 2520 minus 720, that's equal to 1800. There you go. Easy. Percentage is basically probability. I know which question you're talking about. Okay. That is basically probability. Okay, now here's part C. Let's see what part C says. Four letters are selected at random. I have done a stream on geometric. I did geometric yesterday only. And binomial I've also done. I'll see if there's another stream needed. And yes, you should prepare S1. बेटा I mean अभी आप पूछ रहे हो कि किस ऑर्डर में प्रिपेयर करना चाहिए, तो पूछने से बेहतर है कि आप बस स्टार्ट कर लें. जिस ऑर्डर में भी आपने करना है आप कर लें, बस आप स्टार्ट कर लें. ठीक है. Okay. Now, 4 letters are selected from the 9 letters in the word crocodile. Find the number of different selections. So this is not probability, okay? Find the number of selections in which the number of C's is not the same as the number of O's. Okay, number of C's is not the same as the number of O's. So let's start with 1 C and 0 O's. ठीक है, अच्छा ये ज़रा थोड़ा बल्कि 1 C कर लेते हैं ना, 0 लिखने की ज़रूरत ही नहीं है. So if it's 1 C and 0 O's, that means बेटा रिवाइज भी उसी ऑर्डर में करो जिस ऑर्डर में आपने पढ़ा था. ठीक है, पूछने से बेहतर है कि आप बस कर लें. अगर आपको 2 दिन भी जवाब नहीं मिलेगा तो आप स्टार्ट नहीं करेंगे क्या? ऐसा तो नहीं है ना. यू विल स्टार्ट, राइट? सो जस्ट स्टार्ट इमीडिएटली, सिंपल एज दैट. नाउ हाउ मेनी लेटर्स आर वी सिलेक्टिंग फॉर? अच्छा, रिमेंबर व्हाट आई सेड. सबसे पहले टोटल निकाल लो. Okay, so that you can at least guarantee yourself 1 mark. Even if let's say you get the favorable wrong, once you get the total right, you'll guarantee yourself 1 mark. So you're selecting 4 from 9. Okay, doesn't matter कि कितने repetitions हैं क्या हैं. So just do 9C4. Let's see what's that equal to. So 9C4, that's equal to 126. All right, now. So 1, 2, 3, 4. Now, if we select 1C, we have to make sure that we don't end up selecting another C, and we also have to make sure that we don't end up selecting any other O. So that means the remaining 3 letters will come from the remaining 5 letters. 5C3, what's that equal to? ऐसे honestly मैं आप लोगों को एक बात बताऊं. If you do enough questions like these, there will be no element of surprise. Okay. Oh yeah, this is not probability. Okay. Sorry, I thought this is probability. Oops, sorry about that. Someone's paying attention. Now, let's increase the number of C's, so that let's jump it up to 2 C's. So 1, 2, 3, 4. So 2 C's. Now, once again, we're down to 2 letters. We're down to 5 letters. We have to select 2, so that's 5C2, which is also equal to 2. Now, can we select 3 C's? No, that's not possible. But we can select 2C and 1 O. So if I select 2C and 1 O, that means 1, 2, 3, 4. So C, C, and O. So once again, we're down to 5 letters. We have to select 1, so that's 5C1, which is equal to 5. No, we're not going to do 2C1 because we're not finding probability over here. Okay, remember, we count the same letters twice when we're talking about probability. We're not talking about probability here. Okay. Now, let's select one O only and 0 C's. Let's see how that works. 1, 2, 3, 4. 1 O, so we can't select a C. That means we're down to 5 letters. So 5C3 once again, which is equal to 10. Now let's select 2 O's. Okay. So 2 O's would be 1, 2, 3, 4, 0, 0. So this would be 5C2, which is also equal to 10. Now how about we select 2O and 1C? Is that possible? Have we done that already? No, we haven't. 2 O's and 1 C. And I think that's it. 1, 2, 3, 4. 2 O's and 1 C. So that means we just have to select 1 from the remaining 5. So that's 5. Any condition that I've missed? Let's see. We can't have 2 O's and 2 C's because we have to have different number of C's and number of O's. There are only 2 C's to consider. There are only 2 O's to consider. Any condition that I've missed? I don't think I've missed a condition. What do you guys think? Let's add them up. Let's see what do we get. 10 plus 10 plus 5 plus 10 plus 10 plus 5. That's equal to 50. There we go. As far as I remember, I think 50 is the correct answer. Okay. Now, part D. Part D says, find the number of ways in which the 9 letters in the word crocodile. सारे पैसे इस सवाल के. Divided into 3 groups, each containing 3 letters if the 2 C's must be in different groups. Okay, so the 2 C's must be in different groups. All right, now this should be fun. So let's start. Acha dekho. First, before we start doing this, so but aren't we choosing 1C? Beta, this is not probability. We only do that. We only do 2C1 or 3C1 when we're doing probability. Okay. Only in probability do we have to consider repetitions. Okay, please remember that. All right. So we have to make 3 groups of 3. Okay, so 9 letters can be divided into 3 groups, each containing 3 letters, if the 2 C's must be in different groups. Now, this would have been a very straightforward question if there were no repetitions other than the C. Now, because there is a repetition, because we have 2 O's, so we have to sort of pick and choose and place the O's manually. Okay, we can't just let the O's loose and, just arrange themselves on their own. No, we have to do it manually because we're making groups. Okay, so let's start by making a group of 3. Now, let's start by making 3 groups of 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, now let's put them. So here's one group. Okay, so no need to make a box around it. That's kind of useless. So this is one group. This is the second group. And this is the third group. All right. Now, so let's place the C in group 1. Let's also place the C in group 2. Okay, so remember the rule is that the 2 C's must be in different groups. Okay, so I've placed 1 C in group 1, 1 in group 2. So how do we deal with the O's? So we have to consider all possibilities. We have to consider a possibility where the 2 O's are in group 1 with the C. We have to consider the possibility that you have 1 O here and 1 O here. And we also have to consider the possibility that you have the 2 O's over here. Okay? अच्छा और कौन सी possibility हम consider कर सकते हैं? We have to consider the possibility that you have 1 O here and the other O over here somewhere. Okay? So basically we have to one by one consider all possibilities, especially for the O's. So let's start by placing an O with group 1 with C and group 2 with C as well. Okay? Now, if you think about it, if you think about this group and the other group, they are kind of identical. ठीक है, पहले ज़रा हम इसकी combinations निकाल लेते हैं, then there is something else that we have to consider. So basically, we started with how many letters? We started with 9 letters. Okay, so we started with 9 letters. Let's bring this here. Now, of the 9 letters, 2 C's are gone. Okay, and the 2 O's are gone. So let's see how many letters are we down to. So 2 C's are gone, okay, and the 2 O's are gone. So that means we're once again down to 5 letters, okay. So yeah, it's definitely a time-consuming question. I think it's one of those questions that so कुछ questions होते हैं जिनमें मुझे लगता है एग्जामिनर को बनाने के बाद जब solution सामने आते हैं ना तब उसको एहसास होता है कि उसने क्या किया, ठीक है. And I think this is one of those questions. So let's put we're down to 5 letters. That means we can have 5C1 here. Okay, so now we're down to 4, so that's 4C1, and now we're down to 3, so that's 3C3. Okay, so the working for this would be equal to 5C1 into 4C1 into 3C3. Not only is this very time consuming, but there's also not enough space given. So time consuming to ek alag masla hai, there's also not enough space given. Okay? Achha, but here's the thing. We also have to divide this by 2 factorial. Why do we have to divide this by 2 factorial? Let's figure that out. Why do we have to divide this by 2 factorial? Let's see. So basically, there is a possibility, if you think about this group and this group, there is a possibility that, let's suppose, you have COR, okay? So you have R here, okay? And you have, let's say, COD here. Okay, and the reverse is also possible. Like what if, for example, in the first group, with the C and O, you have a D, and then you have COR. Okay, now if you think about it, this is kind of the same. I mean, this is one group, okay? I mean, this is one group, this is the other group, and then this is one group, this is the other group. So these are technically the same, okay? So हम ग्रुप्स की बात कर रहे हैं, ठीक है. अब आप सोचें एक ग्रुप है जिसमें A, B, C हैं, D, E, F, ठीक है, और दूसरा हम कह रहे हैं कि नहीं चलो ग्रुप ऐसे बनाते हैं कि एक ग्रुप में हम D, E, F को डालें और फिर A, B, C को डालें. So it's kind of the same thing. So what we're doing is, because they're basically the same, therefore we divide it by 2 factorial. Okay, therefore we divide it by 2 factorial. Why 4C1? Because we had 5 letters, so we had to select 1, so that's 5C1. Now we have 4 letters, we have to select 1, now we have 3, and we have to select all 3 of them, so 3C3. Okay, so because this is the same, therefore we're doing 2 factorial here. Okay, so what's that equal to? This is equal to 10. Okay. So once again, अगर आप इन 2 groups को देखें, and if you look at these 2 groups, they're kind of the same. Okay, they're kind of the same. So that is why we're dividing by 2 factorial. Okay, so we have to consider all possibilities. So abhi to we haven't even done like 25% of the question. So हल का आप जो बात कह रहे हैं ना, we will consider it. So now let's copy paste it. So now let's delete this, let's delete this, let's delete this. Now let's do one thing. The 2 O's, why divide by 2 factorial? Of course you'll divide by 2 factorial. Why would you multiply by 2 factorial? You'll divide by 2 factorial to take into account the repetition. Okay, you'll divide by 2 factorial to take into account the repetition. Because this and this is the same. So because it's the same kind of group, so therefore you'll divide by 2 factorial. Okay, you're not going to multiply by 2 factorial. All right, now let's do one thing. Let's have the 2 C's separate. Acha, okay, you're saying divide by 2 factorial. ठीक है, okay, सही है. That's the same thing. I thought you meant we should multiply by 2 factorial. Okay. Yeah, no doubt this is a one-of-a-kind question. Okay, no doubt this is a one-of-a-kind question. ठीक है. अच्छा, अब एक काम करते हैं. Let's put the 2 O's with the C in the first group. Okay. So that way what we have to do is we only have to worry about selecting 2 letters from the remaining 5 for group 2 and selecting 3 letters from the remaining 3 for group 3. And what's that equal to? We don't have to worry about any repetitions here. So 5C2, that's 10. 3C3, that's 1. So that's equal to 10. That's it. Okay. Now what other possibility should we consider? The other possibility that we should consider is this. Is that if we have the 2 O's in a separate group altogether. ठीक है, काफी सोचने वाला सवाल है वैसे. I don't know how many percentage of students got this right. Okay. Now, This is also a possibility, right? But once again, here, if you look at these two groups can possibly be identical. Okay, these two groups can be identical. Why can they be identical? I'll explain. So first, let's fill up the remaining places. So we have 5 letters to select. We have to select 2 for group 1. We have to select 2 for group 2 also. But now we're down to 3 letters. So that's 3C2 and then 1C1. But here's the thing. So before you do 5C2 into 3C2 into 1C1, realize that these two are kind of the same. Why? Why is that? That's because it's possible that, for example, let's say you have CRI here and CDE. Okay, just an example. Okay, and you could have the other way around also. You could have CDE as one group and CRI as another group. So these are the same. Okay, since we're talking about groups, so having a group with CRI and another group with CDE and then changing the order does not mean that it's a different group. It's the same group at the end of the day. Okay, so if you change the order of the group, it doesn't mean that it's a different group. It's the same group. Okay? ये इससे same है, ये इससे same है. So therefore, because these two are the same, we will divide it by 2 factorial. Or 2, same thing. Because they're the same, so therefore we'll divide by 2 factorial. Okay? Okay, so 5C2 into 3C2 divided by 2, that's equal to 15. अच्छा, एक चीज़ मैं आप लोगों को बता दूँ. इसकी basis पे ना, whether or not you understand the question does not, if for example you don't understand the question, that does not mean you don't understand permutation combination. This is like 1 in a million. Okay, this particular question is just 1 in a million. Okay? Now, अब here's the thing. Here's another problem with this question. There's not enough space. So we'll have to add an extra page. So मैं बता रहा हूँ ना आप लोगों को, मुझे लगता है कि ये क्वेश्चन एग्जामिनर को देने के बाद एहसास हुआ कि उसने गलती कर दी है. And I hope whoever gave this question got fired. ठीक है. Or at least was fined, not fired, at least fined. ठीक है, because it's an insanely difficult question. इतने मुश्किल questions तो आपके खैर ऐसे टीम में भी नहीं आते हैं. अच्छा, अब एक possibility और क्या हो सकती है? There's another possibility. The other possibility that we have to consider is that you have, let's split the O's. Okay? एक O को हम C के साथ डाल देते हैं और एक O को हम completely independent group में डाल देते हैं. Okay? So let's put one O in group 1 with C and let's put one O independently in the third group because that's the only thing that we were left with. So we had divided O's in group 1 and group 2. We had put O with C with one group with C. Okay. And we had put O's together in a completely in the third group. So the only thing that's left for us to do now is to basically put an O with a C here. Pencil ko kya ho gaya? Yeah. So the only thing that we're left with, just a second. मेरी pencil ने काम ही करना छोड़ दिया. Why? So the reason why we're dealing with the O's separately is because there are two O's. That's why we're dealing with the O's separately. Okay, and the reason why we have to keep the C's separate, that's because we have to. That's because that's what the question says. ठीक है, अच्छा, you're very welcome to try out some other possibility. ठीक है, मैंने काफ़ी कोशिश की है, मुझे तो नहीं समझ आया. This is the one that makes the most sense. ठीक है. There is an alternative way, just skip the question. Yeah, that's the alternative way. Okay, the only alternative way is to just skip the question. Okay, now here thankfully we don't have to consider any repetitions. So 5C1 to fill the remaining spot for group 1, 4C2 to fill the 2 remaining spots for group 2, and then finally 2C2 for this. So 5C1 into 4C2, thankfully no repetitions to consider over here. And what's this equal to? This is equal to 5. Okay, I better not do this mentally. I think this is equal to 30. 5C1 into 4C2, that's equal to 30. So 30 plus 15 plus 10 plus 10 plus 15. So 35 plus 30, that's equal to 65. Okay, is that the correct answer? वैसे मैंने इतना भयानक सवाल है कि मुझे इसका आंसर याद हो गया. 10 plus 10 plus 15 plus 30, which is equal to 65. Okay. Okay, so the reason why we're considering, the thing is, there's no point in checking the examiner report, Ibrahim. Normally I do like to check the examiner report. अच्छा 80 जो आप लोग बोल रहे हैं ना, 80 was the old marking scheme. The marking scheme was later updated and the updated marking scheme had 65 because 80 is incorrect. Okay, 80 में उन्होंने वही गड़बड़ की थी कि उन्होंने O की repetitions को नहीं consider किया था. Okay, so 80 basically answer पता है कैसे आएगा? If you don't do this, if you don't divide by 2 factorial and if you don't divide by 2 factorial, that's how you get 80. Why? Because this becomes 20, so 10 and 15 more, so you get 80. Yeah, 10 and 15 more, so you get 80. 15, yeah, something like that. Okay, so basically that's the problem with that. Okay, if you don't consider the O's, the repetition of O's, that's how you get 80 as the answer. Okay. Achha, I don't know how they ended up marking for this. I don't know how they ended up marking for this, but here it is. Now, once again, there's no point in wasting time on this question. Honestly speaking, there's no point in wasting time on this question. And also, don't judge your understanding of this topic on the basis of this question. Okay, that's what I would advise you. Because it's really an insanely difficult question. Okay. Reason why we consider O's separately is because O's are being repeated. Okay, if let's say O's were not being repeated, then we wouldn't have to worry about it. Okay, so because O's are being repeated and we have to, and when there are repetitions, you have to be careful. That's why we're considering O's separately. Okay, so now let's do that another percentage question. Okay, where it says find the percentage arrangements. I think I'll do a part 2 of this also, perhaps close to exams, inshallah. So tomorrow there's a mock. I'm thinking to keep the mock at 12. Kya khayal hai? अच्छा ये भी करेंगे that the 3 R's are in the same group. Yeah, we'll do this also. May June 2024 paper 5 variant 3 39 part C. Yeah, so let's do that. 12 p.m. not 12 a.m. 12 a.m. sir Zain कर सकते हैं, मैं तो नहीं कर सकता at least. 12 p.m. yeah, tomorrow in the afternoon. What do you guys say? How many yearlies? As many as it takes to reach a consistent score and to be able to finish the paper in time. Yeah, we'll do, I haven't done a seating type question. We'll do that after this question. How many different arrangements are there of the 9 letters in the word intellect in which the 2 T's are together? So this is October-November 2024, paper 5, variant 1. I think one of you requested me to solve this question also. Yes, okay. If you've seen the playlist, now you can start watching past papers. They will start making more sense. So the 2 T's are together. All right, easy. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's put the 2 T's in a box. Now the 2 T's in a box can shuffle amongst themselves. That's 2 factorial divided by 2 factorial. Okay. This is the recorder's question. Okay, recorder's question. Yeah, I'll do that also. 1, 2, 3, 4, 5, 6, 7, 8. So into 8 factorial. Now any other letter that's being repeated? Yep. L is occurring twice. So that means we have to divide by 2 factorial also. So let's see what do we get. We get 8 factorial divided by 2 factorial. That's equal to 20,160. Okay, let me just make sure I haven't skipped anything. So L, no, wait a minute. E bhi to hai. E ko bhi to consider karna hai. So we'll divide by 2 factorial again. Yeah, E ko bhi to consider karna hai. So that's equal to 10,080. 10,080. There you go. Okay. How many different arrangements are there of the 9 letters in the word intellect in which there is a T at each end and there are the 2 E's are not next to each other? अच्छा अब ये इसको skip करते हैं, ठीक है, ये बहुत हो गई. I'm sure आप भी पक गए होंगे, मैं भी पक गया हूँ इस तरह के question करा के. So let's just skip this, ठीक है. We've done this too many times already. Okay. We've done too many of these. done too many already. Okay, yeah. Now this is the part that I actually want to solve. So it says 4 letters are selected at random from the 9 letters in the word intellect. Find the percentage of possible selections which contain at least one E and exactly one T. Okay, so percentage of possible selections. What does that mean? Percentage of possible selections. That basically means probability. Okay, so once again, the examiner probably thought that how can we make a simple question complicated? So somebody probably came up with the genius idea that instead of using the word probability, use the word percentage of the possible selections, and I'm sure students would go crazy. I'm pretty sure that's what must have happened. ठीक है, बच्चों ने आके बोला होगा सर ये क्या आपने probability नहीं percentage of possible selections तो कभी कराया नहीं आपने. I'm sure ऐसा हुआ होगा. So 9C4, what's that equal to? That's equal to 126. We've done so many already. याद ही हो गया अब. Okay, so at least one E and exactly one T. Now once again, this is fixed. Exactly one T is fixed, and at least one E is variable. So we'll keep the T fixed at 1. We'll keep on increasing the E's. So let's start with 1T and 1E. Okay, so if we have 1T and 1E, so 1, 2, 3, 4. So 1T and 1E. So how many ways can you select 1T from the 2 T's? So that's 2C1. Now why are we doing 2C1 here? We're doing 2C1 because it's probability. Okay, and how many ways can we select 1E? That would also be equal to 2C1. Okay, now we're down to how many letters? We're down to 5 letters. So a good idea would be to rewrite this word next to it. Okay, and then take a look at the number of letters that you've dealt with. So we've dealt with T's, so we're going to cross that out. We don't want any more E's, we're going to cross that out. So we're down to 5 letters and we want to select just one. We want to select 2, so that would be 5C2. Okay, so what's this going to be equal to? Let's drag this here. Let's make some room. Okay, so 5C2, that's 10. 10 into 2 into 2, so that's 40. There you go. Sorry to get you back, but why don't we consider the fact that 2 C's can be on any 3 groups? It doesn't matter. Because, okay, let me read your question carefully. Why don't we consider the fact that 2 C's can be... We did consider the fact that 2 C's can be in any 3 groups, but we have to place the O's manually because O's are being repeated and we don't want to end up double counting, so that's why we do it manually. Now, what if you have 1T and 2E? Okay, what if you have 1T and 2E? So 1, 2, 3, 4. So 1T and 2E. So 1T, what's the probability of selecting 1T? That's 2C1. And what's the probability of selecting 2E? So that's 2C2. And now we're down to 5 letters and we have to select 1, so that's 5C1. So 5C1 is 5, 2C1 is 2, 5 times 2, that's equal to 10. So that means 40 plus 10, that's equal to what? That's equal to 50. So 50 is the favorable outcome divided by the total outcome, that's 126. Let's see what do we get. So can't T and E shuffle places? But we're talking about selection. So even if they do shuffle places, it's the same selection. Okay, so even if they do shuffle places, because we're selecting them, it really doesn't matter. I would strongly encourage you guys to watch the whole playlist of permutations and combinations. I think those of you who haven't done this chapter from scratch shouldn't be here, honestly. But if you are, then I will advise you to go back and watch that playlist where I've covered basically permutations and combinations from scratch. Okay? And then come back. How do you tell the difference between permutation and combination? If you're talking about selection, that's permutation. If you're talking about arrangements, that's permutation. Okay, that's how it works. Simple. All right, I'm going to do one more question. Okay. But we'll do a part 2 of this. Acha, what's that? Yeah, you guys are right. L को हमने separately क्यों नहीं consider किया? Just a minute. Let me see. 1, 2, 3, किया है हमने separate. So basically here's what we're doing. We're talking about 1, 2, 3. 1, 2, 3, 4, 5. Yeah, so there are 5 letters. Okay, now from the 5 letters, we have to select 2. So we did consider the 2 L's. That's how we got 5C2. Okay. Why not multiply by 100? What do you mean? I hope you're joking. What do you mean, why not multiply by 100? Question 38. अच्छा ठहरो, मुझे बस एक सवाल और कराना है आप लोगों को. Let me just quickly pick that question. Andromeda वाला करा लिया. अच्छा, एक सीटिंग अरेंजमेंट वाला करा देता हूँ मैं आप लोगों को. ठीक है, let's do question number 33. Let's do question. Okay, reason why we did not divide by 2 factorial, that is because... Acha, okay, I get what you're saying. Multiply by 100 because it says percentage. Okay, yeah, you're right. You're right. We will actually multiply by 100. Okay, so you have a point. Since it says percentage, we will multiply by 100. ठीक है, multiply by 100 कर लेते हैं इसको. Just a minute. मैं ढूंढ रहा हूँ कोई अच्छा सवाल. So let's multiply this by 100. Acha, sorry, I didn't realize that the question... I did realize what the question was, but I kind of forgot myself. So the answer is 39.7%. ठीक है, thank you. Okay, so one more question and then we'll do a part 2 of this. एक वो seating arrangement वाला question था जो मैंने आप लोगों को अभी तक कराया नहीं है कोई seating arrangement. So let's do that. Here it is. Okay, reason why we don't divide by 2 factorial is because we're dealing with probability. In probability, we have to consider repetitions. Simple as that. Okay? Because we're dealing with probability, so we have to consider repetitions. Simple. If we were not dealing with probability, then we would do that manually. Okay? Alright, let's solve this question. I will do part 2 most likely not tomorrow, but on Monday. When's the exam? The exam's on the 14th, right? So I will do part 2 most likely on Monday, inshallah. Alright, in a restaurant, the tables are rectangular. Each table seats 4 people, 2 along each of the longer sides of the table. See diagram. 8 friends have booked 2 tables, X and Y. R, S, and T. So I'm just going to call them by their initials. R, S, and T are 3 of these friends. Okay. The 8 friends will be divided into 2 groups of 4. 1 group for table X, 1 group for table Y. Okay. Find the number of different... So there's a lot of information that you... And you have to make sure that you understand the question very carefully. Okay. Because sometimes... In fact, a lot of times you will not be able to answer the question because you don't know the concept, but you will be unable, sadly, you will be unable to answer the question because you are unaware or you probably didn't understand it correctly. Okay? So it's lack of English, lack of comprehension, basically, that may get you down sometimes. So find the number of ways in which this can be done if R and S must sit at the same table as each other and T must sit at the other table. Okay, so R and S must sit at the same table as each other and T must sit at the other table. Okay, first of all, notice that we're dividing them into groups. Okay, now the fact that we are dividing them into groups means that this is a combination question. Okay, so technically we have to make 2 groups of 4. Okay, technically we have to make 2 groups of 4. That's what we have to do. Okay. But in one group of 4, we have to make sure that we keep 2 people. Okay, and then the other person, we make sure that we keep that person in the other group. Okay, so let's first, and the groups are basically X and Y. Okay, the groups are basically X and Y. So ek kaam karte hain, let's talk about X and let's keep R and S at table X, but not T. Okay, let's keep R and S at table X, but not T. Okay, how do we make sure that R and S are selected for table X? That would be 2C2. Okay, and remember that there are a total of 8 people. Okay. Now, if R and S have already been dealt with, that means now you're down to 6. Okay. Now, from these 6 people, now remember, you still have to select 4 more people for this group. Okay, so table X has 4 people, and we have to select 4 people for this group. So first we make sure that R and S are selected. Now we have to make sure that we don't end up selecting T. Okay, so that means once R and S have been selected, we remove them from the group. Okay, so that means now we're down to 6 people, but from these 6 people, there is T who must not be selected. So that means I must remove T also, 6 minus 1, so that means now we're down to 5 people. Okay, so this is for R and S. Okay, and here what we're doing is we are basically removing T. Okay, so 8 minus 2 is because R and S are selected. Okay, and now we're removing T, so that's why we're doing 6 minus 1, so that we're down to 5 people. And we have to select how many? We have to select 2. Okay, and then as far as table Y is concerned, so this is table X. As far as table Y is concerned, so table Y would simply be 4C4, which, doesn't really make a difference whether you do it or not. So let's work this out. Let's see what we get. So when you do 2C2 into 5C2 into 4C4, that's basically equal to 10. Okay, that's basically equal to 10. Okay, now let's do the same scenario, except let's do this for table Y. Okay, so for table Y, let me first complete this question, then I'll take your questions. Okay, because I'll lose my chain of thoughts. And I'll advise you guys to do the same. Jab tak when you're solving this question, just stay focused. Don't think of anything else. Don't look here and there. Otherwise, you'll lose your chain of thoughts. Now, here you will do the exact same thing. 2C2 to select R and S, then 5C2 to select the remaining 2 people from the remaining 5, because R and S are excluded. They're no more included in the people we're selecting from. And we also remove T so that we don't end up selecting T for table Y. Okay, so this is for table X and this is for table Y. So for Y, this is for table Y. Now you can simply multiply it by 2 also, but just so you know what's going on, that's what I'm doing. That's why I'm doing this. So 5C2 is 10. So once again, this is also 10. So that means the total is equal to 20. ठीक हो गया, मजा आया? Another difficult question, right? Okay, now let's see what's next. When the friends arrive at the restaurant, R and S now decide to sit at table X. Okay, R and S. Acha, what's that, Zainab? Is this always the case whenever you're dividing into groups that include a combination? Yeah, so whenever you're dividing into groups, that means you're selecting. Okay, so if let's say I make a group of A and B, and then somebody else comes along and says, you know what, that's not a good group, let's make a group of B and A. Is it even worth having a debate over this? Of course not, because it's the same group. And when it's the same, when the order is the same, that means it's combination. Simple. Okay, let's see what's next. So what's next is, when the friends arrive at the restaurant, R and S now decide to sit at table X on the same side as each other. Dan decides that he does not mind at which table he sits. Find the number of different seating arrangements for the 8 friends. Okay, now, so here's X, here's table X, here's table Y. Let's just roughly draw the tables. It's not that difficult. So here's table X, and here is table Y. Okay, now R and S decided that they are going to sit at table X. Okay, now since they've already decided that, let's place R here, let's place S here. Now don't forget that R and S can shuffle amongst themselves. So that means we'll have to consider 2 factorial. Okay, now what's this 2 factorial for? Because they can be seated as RS and they can be seated as SR. And also, they can also be seated here. Okay, they can also be seated here instead of where they are right now. Okay, they can be seated on the opposite side. That means we'll multiply by 2 also. Okay, now remember we started with 8 people. Now 2 of them have already taken their place. Now we're down to how many? We're down to 6. So that means for this place we have 6 options. For this place we have 5 options, then 4, then 3, then 2, then 1. So that would simply be equal to 6 factorial. Okay, so this 2 factorial is for this. This 2 that you're looking at is to basically take into account that you can have RS here. Okay, or, and this side can be empty. I mean, The remaining two friends can sit here, or you could have two people here and RS sitting here. Okay, that's what this 2 is for. ठीक हो गया? And then 6 factorial for the remaining 6 people. So that's 6 factorial into 4, that's equal to 2880. ठीक हो गया? Now, are we done? No, there's more. Ali, let me guess. Ali from IGCSE? From O-level math? As they leave the restaurant, 8 friends stand in a line for a photograph. They can also sit vertically. They can't sit vertically because they have to sit together on the same side. Okay, they have to sit together on the same side as each other. So that means next to each other. Yeah, you can write 2 factorial into 2 factorial. Okay, you can do that. You can write 2 factorial into 2 factorial. There you go. Same thing. As they leave the restaurant, the 8 friends stand in line. For a photograph, find the number of different arrangements if R and S stand next to each other, but neither is at the end of the line. Okay, R and S stand next to each other, but neither is at the end of the line. Okay. Discrete random variable. Haven't I already done a stream on discrete random variable? Why? शायद मैंने किसी और नाम से किया, मैंने probability distribution के नाम से किया, but I have done it. I'll double check. I mean, I know a lot of you have been asking, so I'm just wondering why. S1 की जो live streams वाली playlist है वो check करो, उसमें मैंने की भी नहीं है already. Okay, so the 2 of them cannot stand at the straight line, so that means amongst the 8 friends, we have to choose from the remaining 6 to stand at each end of the line. Okay, so that means we have 6 options here, we have 5 options here. Okay. Achha, sir, why did we not? Once again, see, cinematic creations, you will get the question wrong because of not understanding the concept, but because of lack of paying attention of what the question says. Okay, a good idea, deleted that, वरना अभी मैं और बातें सुनाने वाला था. Okay, now. So R and S have to be together, so they can be together 2 factorial number of ways, all right? And they can be together in multiple places, 1, 2, 3, 4, 5. So that means 6 into 2 factorial into 5 factorial, since we have 5 units to shuffle, and then into 5. Okay, so let's work this out. Let's see what we get. 6 into 2 factorial into 5 factorial into 5. So what's that equal to? That's equal to 7,200. There you go. So I'll do a stream on discrete random variable as well. Okay, I'll do that inshallah in the coming days. So there you go. There you have it. Acha, I think aaj ke liye kafi hai. Firing started again. Really? Why 5 and 5 factorial? Okay, I'll explain. So first of all, we have 6 options here because from these 8 friends, R and S cannot stand at the end of the line. So we have to pick from 6, from the remaining 6, and then we have 5 options here. So we have 6 options here, okay, and we have 5 options here. Now, there are R and S who have to stand together. So that means 2 factorial, okay. And as a unit, along with other friends, they can shuffle, or they can, so basically R and S together and the remaining friends can arrange themselves 5 factorial number of ways. Okay, remember, we treat them as a unit. So this is 1 unit with R and S, and then 2, 3, 4, 5. So these are 5 units. And how many ways can you arrange 5 units? 5 factorial. And then what's this 5 for? This 5 is basically for the end of the line. There you go. I remember yesterday you said there will be a discrete random. Achha, sorry, I probably forgot. So yeah, I do have something similar for S1 also. I will share that with you guys inshallah in the next stream. Okay. Yeah, you can use 6C1 and 5C1 also. Okay, you can do that. अच्छा, आज के लिए इसको यहीं तक रखते हैं because it's time for my class. It's 8. Yeah, it's 8. So 6 into 2 factorial into 5 factorial into 5. What's that equal to? That's equal to 7,200. Just double checking. Now, I will encourage you guys to solve the remaining questions. Okay, and please don't judge your level of understanding on the basis of those insanely difficult questions. Okay, so we will pick this up inshallah in the next class. Acha beta, I will do a part 2. Okay, so whatever requests that you guys have, I plan on inshallah completing this entire PDF. Okay, so I will do a part 2 inshallah. So don't worry about it. Okay, we have time. We have 11th, 12th, 13th. Yeah. Okay, we don't have a lot of time, but yeah, we have enough time to do a part 2. Acha, jate jate, I would really appreciate if you guys like the stream if you haven't done that yet, and also subscribe to the channel if you haven't done that. Remember, tomorrow you guys have a mock. Timings I will confirm. It's either going to be at 12 or it's going to be at 1. ठीक है, 1 नहीं होगा, 1:30 हो सकता है, but not 1. Okay, so I'll stop here. ख्याल रखें, be safe, stay indoors even if things have settled down. It's a good idea to stay indoors for a while. So take care. See you guys inshallah tomorrow. Allah Hafiz.